This is the High Pressure Technologies MTNB system. We have here a DLE 5-30 model booster, which means that we have a 5 ratio on this end and a 30 ratio on this end for the gas compression. The MTNB systems come with an air filter, an air regulator, gauge, an on-off valve, which can also be used for controlling the speed of the booster. Also, there is a pressure switch, a relief valve, a vent valve, and an outlet pressure gauge. I have here set it already all up. Basically, the standard systems come with a 1/4 inch NPT connection for the gas lines here, and a 1/2 inch NPT connection for the air inlet, and then of course a 1/4 inch NPT on the outlet for the gas. So I've already have a air connection hose already connected to the system. Typically with a 2-stage booster, usually coming from a generator, so the pressure will be pretty low, or you're coming from just low pressure gas, or you're boosting to very high pressures from standard K bottles. In this case, we are coming from a K bottle. However, being that this is the 5-30 model, the gas inlet is typically between 30 and 100 psi. So as you can see here, I have about a 75 psi of compressed air, of nitrogen coming into the booster. And then I also have set onto the air regulator about 110 psi for that. Now, the way that the formula works for the gas outlet is, looking here at the sheet, you'll see that the DLE 5-30 model is a 30-to-1 ratio, so you're going to get 30 times that approximately on the outlet of the gas. It has a 30 times the air drive plus 6 times the gas supply. So the way you calculate the outlet pressure is it'll be 30 times the air drive plus 6 times the supply. Here I have 110 psi in the air, so that would go there. And then I have 70 psi on the nitrogen, which then goes there. So with using that formula that they give you right here, basically your outlet pressure fully calculated up would be about 3,720 psi. Now, on these systems, as you can see, there is a relief valve that is set for 4,500 psi, and the air pilot switch, which is what tells the booster to turn on and off, is at 3,500 psi. So this booster is actually going to be pressurizing up to 3,500 psi and then shutting off. Should this ever fail, the relief valve would keep it from being able to overpressurize any higher than whatever it is that you're pressure testing. These are all field adjustable, so with our systems, you can specify what pressure range you want it to shut off at, and what pressure is the maximum pressure for your test that it's able to take, to make sure that you're not going to be damaging any of your components. So as you see, I have my 1/2 inch air line coming in. The air is actually on, so this should actually be off. Sorry about that. But as you can see, the gas outlet is already at the 3,500 psi. And then also there is a vent valve here. So what I'm going to do is I'm just going to vent off some of this pressure here, so that way you can see how the booster does operate. So the air is off, so the booster is not going to operate. And I've just blown off a little bit of the air, and now you can see that it's around 2350. So I'm going to go ahead and kick the air on, and as I said earlier, this is also a speed control valve, so that way you can control how fast the booster operates. These things can go about 100 cycles a minute, but that's if it's running full out. You really don't want to be running it at 100 cycles a minute. Typically, between 30 and 50 is a really good cycle rate. So I'm going to go ahead and kick this on. As you can see, it's cycling at a decent speed now, and then as you increase the air, it does go a little faster. Can you kick this on? I'm going to kick this air compressor on here because we don't have all that much air here in the facility. it's going to get a little loud, but you'll see the booster does increase in the speed. What's going to happen is it's going to pressurize up to 3,500 psi and stop, even though the booster is said to be able to go to 3,720. So if I didn't have that air pilot switch there, it would pressurize all the way up to 3,720 and stop. But as you can see, it is actually going to pressurize up to that pressure, and then it is going to stop. Now as the booster starts getting closer to that stall pressure, it does start to slow down, which is typically why you want to give it a higher pressure on the outlet on your formula here than what you actually have your pressure test or your pressure switch set at. Reason being is that way you can overshoot your pressure. It doesn't slow down like it does right now. So once again, I'm going to close this off now, and I'm also going to vent off all this pressure so that way you can see exactly how fast the booster operates when it's at 0 psi and also all the way up. So once again, I have the regulator there. Now if I open this regulator to as much pressure as possible, that's going to really increase the cycle speed. And I actually lowered it there. So here we go. And as you can see, that's the booster running basically full out. Now our systems come standard with the air regulator, air filter, air regulator with a gauge, on-off valve. You have your pilot line here that comes out, which actually runs around and comes into the side of the switch. And then coming out of the switch, it comes around to the other side of the booster, which is your pilot line, which is what kills it off. Now once it hits that 3,500 psi, it actually shuts the booster off. It actually closes this valve, which then turns the booster off. As you can see, the gas comes out of the 5 compression end, comes through a cooling sleeve, so all the exhausted air is actually vented through the sleeve right here, and also through the gas barrel sleeve, so it actually cools down the booster at the same time, which is a really nice feature. That way you don't get too much heat build up, and it actually vents off the pressure fairly quick. So I'm just going to go ahead and run this all the way up. Now I'm filling a pretty large accumulator there, and it's like a 42 cubic inch accumulator there. So it's got quite a little bit of volume to fill up. Typically, if you're coming from a double-ended, double acting booster and not a 2-stage, you'll find that the flow rate is actually going to increase a lot higher than that. Let's see here. I increase this pressure up. Oh, sorry, wrong way. I'm going to increase the pressure all the way up. So in my regulator's at full throttle, really, it's kind of what you want it at. Reason being is that way you're going to well overshoot that pressure, and the booster doesn't have any difficulty getting to that higher pressure. So you see, if I cut this off, my air pressure is about 100 psi right now, and the higher I go, the better. And as you can see, the booster is going to automatically shut itself off once it hits that 3,500 psi mark. And that should be it. Pretty nice feature. Like I said earlier, these pilot switches are all field adjustable. You adjust them using the hex here. And then same thing with the relief valves. This is actually a lower pressure relief valve. We typically use like 1 to 10,000, or 2.5 to 25,000 psi. The pressure adjusted range is done by a spring, and then also the hex nut here. So if you guys have any questions, feel free to give us a call. Once again, the components for this system is you would connect directly up. There is no gas inlet pressure gauge. However, if you want one with the system, we can supply one. You just specify that. Typically, you would just connect your 1/4-inch NPT female connection going into the booster. You would have your 1/2-inch NPT female for your air drive. And then you would, coming out of the system, you would have a 1/4-inch NPT female gas outlet. The gas, all the components are filter, regulator, gauge, on-off valve, pressure switch, relief valve, vent valve, and an outlet pressure gauge. If you guys have any questions, feel free to give us a call. High Pressure Technologies, 661-257-7600. You have a good day.